Assalamualaikum and welcome back. We are still on objects motion on a curve. Okay, let's continue with the second example, example B. Here we are asked to find a vector position RT if the velocity vector Vt is given as this and the position vector at t equals 0 is equal to I plus 4j minus 4k. So here we're given velocity, we are asked to find RT. So in example A, we're given R, we are asked to find velocity and acceleration. So what we do is we differentiate once to get velocity, differentiate twice to get acceleration. So now it's the opposite. We're given velocity, we are asked to find RT. So what we need to do now is to integrate. Okay. All right. I need more room. Okay, so we're given Vt, we are asked to find RT. Okay, so to get R, oops. Okay, so we know that V is actually R prime. Okay, velocity is equal to R prime. So here we have t squared I plus negative e2tj plus square root of tk. So from R prime, we can get R, which is we need to integrate R prime. So to get R, we need to integrate R prime. And remember, from the integration, just let's look at the notes again. For integration, what you need to do is you need to integrate the x component to get the new x component, integrate the y component, and also you need to integrate the z component. But remember, when you integrate, you have to add a constant. So remember, here we have plus a constant vector. Okay. All right. Now let's to get the x component, we need to integrate the x component. So the x component for velocity, which is r prime, is equal to t squared. So we need to integrate t squared. So that would be our x component. Okay. And for the y component, we need to integrate negative e2t with respect to t. So that is our y component. And for the z component, we need to integrate square root of t, or I'm going to write it this way. Okay, integrate that with respect to t. That would give us the z component. Okay, now let's find the integration of t squared. So that would be t cubed over 3. And don't forget to add a constant. So I'm going to write c1. Okay, that would be the x component. Now integrate the y component. So e negative 2t. That would give us negative e2t over 2. And don't forget to add a constant. So let's say that's c2. So that is our y component. And then integrate the z component. So that would be t a half plus 1. That would be 3 over 2 divided by 3 times 2. And don't forget to add a constant. So I'm going to add c3. So that would be our z component. Okay. And here we can use the position vector when t is 0 to find the values of c1, c2, and c3. Okay, when t is 0, so what you do is you replace t with 0 in our r. So that would give us 0 plus c1, so that would be c1i. Okay, and then replace t with 0 in the y component. E to the power of 0 is 1, so here we have negative a half plus c2. That would be the y component. And the z component, replacing t with 0, that would give us a 0, so we have c3k. Okay, and it says in the question, r at 0 is equal to 1i plus 4j minus 1k. So this is equal to I minus plus 4j minus 1k. So what you do now is to compare these two vectors because they are equal. So if they are equal, all the components should be equal. So from here we can see that C1 must be equal to 1. So C1 is 1. And here negative a half plus C2 must be equal to 4. So C2 minus a half must be equal to 4. So from here we get C2 is 4 plus a half, which is 9/2. And C3 here must be equal to -1. -1. Okay, so now we can update the solution, because remember this is our RT, but now we need to replace C1, C2, C3 with the values that we just obtained. So now we can update our solution. So RT, the one that we want, is equal to t cubed over 3 plus C1. So C1 is 1. So that's the x component. And then we have plus negative a half plus C2. So C2 is 9/2. And here we have negative a half. That is, oh, sorry. That is not my y component. This is our y component. Sorry about that. So y component is C2, which is 9/2, plus a minus e 2t over 2. So that's the y component. And the z component is 2t 3/2 over 3 plus C1, where C1 is -1. So that is our RT. So in this case, we only integrate once, because we're given velocity and we want to find r. But if you're given acceleration and you want to find r, you have to integrate twice. Okay, that's it. Thank you.